All right, here are solutions for quiz 4 from Math 112. You're given 3 logarithmic equations and asked to solve for x. So hopefully this will look kind of familiar to the worksheet that we did in class. On this first one, you want to get this x. But the problem is this x is kind of buried. First of all, it's up in an exponent, and then it's hidden inside of a log. So I'm going to have to do a lot of manipulation to get at it. First thing I'll want to do is get rid of this minus 8. So add 8 to both sides of the equation. That leaves you with 3 raised up to the log base 2 of 3x minus 2. And that would be equal to 9 if I add 8 to both sides. And so now I'm going to take the log base 3 of both sides of the equation. The log base 3 of 3 raised up to some power is just equal to that power. So by taking the log base 3 of both sides, the left-hand side simplifies really nicely. Now it turns out the right-hand side turns out pretty nice as well. Log base 3 of 9 is just equal to 2, because this is asking me the question, what power does 3 need to be raised to make it 9? And 3 squared is 9. So what I now have is that the log base 2 of 3x minus 2 is equal to 2. And I got to solve this. Well, the way I can solve this, now I got to get rid of this log. So I could do 2 to both sides of the equation. It would cancel out nicely on the left-hand side and just leave me with 3x minus 2. On the right-hand side, I would have 2 raised up to this power, which also happens to be a 2. So I would have 3x minus 2 equals 4. And if I added 2 to both sides, I get 3x equals 6. And dividing by 3, I get x equals 2. This next one here, a couple different options in terms of how you do this. I think it's easiest to divide both sides by 2. So you get 9 times 3 to the x power equals 3 raised up to the 2x minus 3 power. And then if you divide both sides by 3 to the x power, what you'd end up with is something that looks like this. And you might recognize that on the right-hand side here, I can use an exponent rule. That anytime you have the same base and you're dividing two exponents, you just subtract the exponents. So I got 2x minus 3 minus x. So I would have 9 raised up to the, 2x minus 1x just leaves me with x. So I'd have 9 equals 3 raised up to the x minus 3 power. And then from here, I want to get at the exponent, so maybe I take the log base 3 of both sides of the equation. Leaves me with log base 3 of 9 equals x minus 3. As we saw above, I think, log base 3 of 9 is just equal to 2. So 2 equals x minus 3, and if I add 3 to both sides of the equation, I get x equals 5. Maybe I'll even say this is kind of option 1. Another way you could do this problem, I don't know that you need multiple ways, but just an FYI, is you could take the log of both sides of the equation, really at any point. Maybe I'll divide by 2 first, just so I have one less coefficient to deal with. I get 9 times 3 to the x power equals 3 to the 2x minus 3 power. Now instead of dividing, I could just take the log base 3 of both sides. What you'll see is that on the right-hand side, things cancel out really nicely. I have the log base 3 of 3 raised up to some power. Well, that all cancels, the log base 3 and the 3, and leaves me with just 2x minus 3. However, on this side, I'm not so lucky. I can't cancel out this 3 and this 3. Cancel out is a bad term to use, but I can't take advantage of my identity. What I have to do is first use my first log rule. I have the log base 3 of something times something else. So I can rewrite that as the log base 3 of 9 plus the log base 3 of 3 to the x power. Now this will simplify pretty nicely. The log base 3 of 9, that keeps showing up here, that wasn't on purpose, is equal to 2. And the log base 3 of 3 to the x power is just equal to x. So I got 2 plus x equals 2x minus 3. Subtract x from both sides, add 3 to both sides, and you get this same answer of x equals 5. Okay, another equation here. You stare at this thing, you see a log on both sides of the equation. They're both log base 2, so you might want to do 2 to both sides of the equation, but it doesn't work out nicely if you do because of this 3 right here. Instead, what you'll want to do is get all the logs together on one side of the equation. Why? I'll show you in a minute. So we got log base 2 of x minus 1 plus log base 2 of x plus 1 equals 3. And now what I can do is use my first log rule. I got the log of something plus the log of something else. I can rewrite that as the log base 2 of x plus 1 times x minus 1. Maybe I'll write that in the opposite order since that's the way it appeared above. I can change this sum of two logs into the product, the log of a product. So I get here. And that equals 3. At this point, I guess you have some freedom in what you do. You could multiply these guys together first if you wanted to, or you could do that later on. I'm going to go ahead and take care of it now. X minus 1 times x plus 1 is x squared minus 1. These are conjugate pairs, and their product is a difference of squares. Anyways, get to here. Now if you do 2 to both sides of the equation, you get x squared minus 1 equals 2 to the third power. So x squared minus 1 equals 8. So if I add 1 to both sides of the equation, I get x squared equals 9. So x equals plus or minus 3. I'm going to go ahead and say full credit if you put this down as your answer. However, x equals negative 3 is not really a solution. Not because I screwed up any algebra, but because if you go and plug those back in the original equation, negative 3 minus 1 more would be negative 4, and I can't take the log base 2 of a negative number. So that doesn't end up working out. So x is not really a solution. Only real answer is x equals positive 3. But I don't care. If you leave it like this is good enough. I'm pretty impressed that you got through all this log stuff. We'll call that good. All right, last one. Suppose that the doubling time of mold in my fridge is 4 hours. Fine. Find the continuous hourly growth rate of the mold. When you see continuous, you're thinking maybe this formula here. And if you're thinking this formula, once you have that, the problem doesn't end up being too bad. And it's just recognizing that this is the formula to use. The other piece of information you need to know is that the doubling time is 4 hours. So what that means is that if I start out with whatever number I want, maybe I start out with 1 just to make things really simple. After 4 hours, in other words, when t equals 4, I would have 2 because it is doubled in 4 hours. Turns out you can start out with any number you want as long as you put this as twice that number. But for simplicity's sake, I'll put that as a 1. So I got to solve for r. How do you solve for r? We'll take the natural log of both sides. I got the natural log of 2 equals 4r. So therefore, r is equal to the natural log of 2 divided by 4. Don't have to go any further than that. That's a perfectly good answer. So I'll go ahead and end this here.